All right. So in this one right here, goes back to using your socks. So if you didn't do your socks, then you would have gotten it wrong. Okay, so the centers, I referenced both, they're roughly the same. The female pulse rates are more spread out than the males. The shapes are approximately symmetric because the mean and median are equal. So it feels like there'll be no difference. Is it appropriate to analyze? So yes, the sample is greater than 30, but again, I believe that they're approximately symmetric, so I'm saying no skew. Yes, at least 280 males and 240 females. Samples are independent of each other. I create the interval using my two sample t interval. And does it confirm my answer in part one? So yes, 0 is in the interval, so it's possible that there's no difference. Okay. All right. So when we look here at this section here, so comparing two means. So we're just back to what we were doing before, my HO. So mu1 is equal to mu2. Remember, you could also write it as mu1 minus mu2 is equal to 0. For HA, we'll have greater than, less than, not equal to. Again, this is a two-sample t-test for means. Again, if you notice, I'm kind of avoiding that z because you need to know sigma. Random check, same as yesterday. Normal check, same as yesterday. Independent, same as yesterday, or I should say last lesson. Here's your formula. Again, we're kind of always sticking with that easy scenario. Remember, this is your statistic. This is your parameter. So in our case, our parameter, we're always just saying 0. It doesn't always have to be that way, but that's what we're saying. There's that standard error there. There's your calculator command. This looks the same as it's always looked. Okay? All right. We talked about this a little bit before. So if the sample size is less than 30, we're doing the same things that we did before. So we're looking at graphs, looking for outliers or skews. So if you were actually gonna, this question's about if you were gonna design something yourself. So if you're designing a study using the two sample t procedures, try to choose equal sample sizes. Make sure that you have either a random sample or you did random assignment, because if you don't have the randomness, the results are not accurate. Don't use these two sample procedures on paired data. Okay? All right, bounty picker-upper. So they're quicker picker-upper, but are they also the stronger picker-upper? So two AP Stat students, Wesley and Maverick, are going to try to find out. So they take a random sample of 30 bounty paper towels and a random sample of 30 generic paper towels and measure their strength when wet. So they uniformly soak each paper towel with 4 ounces of water, held to opposite edges, and counted how many quarters each paper towel could hold until ripping. Here are the results. It's kind of interesting that how many quarters that they're holding, but whatever. This is from the textbook. It's usually these were probably students of one of the authors of the textbook, so we'll just go with it. Okay, you are going to want to type these all into your calculator because you're going to need the X bar and the SX. These are the sums for each list if you want to check to see that you typed it in correctly. But we want to know if bounties are the stronger picker-upper. So I've got mu, and again, you can use whatever symbols you want. You could still stick with 1 and 2. So I'm going to say the true mean number of quarters the bounty paper towels hold, and then the generic, so the generic hold. Okay, your HO is that they're equal. I'm going to treat the bounty as my first one, so that's why I'm putting it there. HA, so I want to know if the bounty can hold more than the generic. I'm doing a 2-sample t test for means. Random, so it's stated for both. They took random samples for both. The normal check, thankfully we're at that 30 mark, so N1 equal N2, and they're both greater than or equal to 30, so that central limit theorem applies here. Independent. These are bounty. You can't be both a bounty and a generic paper towel, so the samples are independent of each other. And then within the sample, each sample, we need to assume that there's at least 300 of each paper towel, which is a safe assumption. I already typed those into my calculator, so they're already in my list. I'm going to go to stat tests. I'm doing a 2-sample t-test, so number 4. I'm going to use the data option. Freak, so I got my L1, my L2, my freaks just stay as 1. My HA said greater than. Always say no for pooled. The color's only relevant if you're going to draw it. And here's my results. Again, you didn't type any inputs in, so tell me what your outputs are. This is going to just end up being 6.3 by the time I round it. Give me the degrees of freedom too. If you notice here, the degrees of freedom here are those funky degrees of freedom. Actually, you should have, back in the confidence interval notes, you should give me the degrees of freedom too. So it's using, the calculator is using those, the more accurate formula as opposed to using the conservative method. Here's my test statistic. Here's my p-value. Extremely tiny here. So the p-value is less than alpha. If I'm less than alpha, I reject HO. There is enough evidence to say the bounty paper towels hold more weight on average. Alright, so the next page is just kind of like comparing. So the other thing, you've learned a lot of tests at this point. So the book puts a section in here on how to choose the most appropriate test. So this is, so here's one way you could do it. So you're designing your experiment. So you're designing experiments to determine if students perform better on tests when there's no distractions, such as the teacher talking on the phone. You have access to 2 classrooms and 30 volunteers. So if I wanted to do a 2-sample t-test here, then I have to take my 30 volunteers and split them up into 2 groups. So I could describe using the label, or calculator, or the table. So I said put number 1 on 15 cards and number 2 on 15 cards. So shuffle the cards and have each student take 1 card. Students with the 1 will go to the classroom without distractions. A student with the 2 will go to the classroom, so with distractions. The student with the number 2 will go without distractions. Take the same test and compare the results. So I've got 15 students being distracted and 15 students not being distracted. So I have 2 separate groups. So Sally's over here, she's not over here. The other way is I could do a matched pair test. So I'm going to use the same cards. Those that get a number 1 go to the room with distractions and take the test. After they're done with that, then they go to the room without the distractions to take the test. Those with the number 2 do it in the reverse order. So they go to the without distractions first, then they go to the distractions room. And then I take the difference in the individual test scores and compare improvements. Probably the matched pair is a better design because it eliminates an important lurking variable, the idea, like the student's testing ability, or perhaps just because they're taking a test a second time, or sorry, no. So just their testing ability, just their ability, their intelligence or whatever is the lurking pair there with the matched pair. All right, and then on the last page here, I have some more examples of these if you need it. So which test would you use for the following scenarios? So here, if you look here, is the recovery time from ACL surgery shorter for patients who have health insurance? So we have 300 patients with health insurance and 200 patients without health insurance were studied for the recovery time after the ACL surgery. These are separate samples here. They're not just one sample, so I've got two separate samples. I want to know if the recovery time, so is the recovery time, so I just am looking for a yes or no answer, so that's a test. I'm not trying to estimate a number. So this is just going to be a two-sample t-test for means, okay? Because I'm just going to compare the recovery time for the one group, the length, and then the length of the recovery time for the other group. How much greater, oh, keyword there, is the average cholesterol of egg eaters versus egg abstainers? So they have 100 volunteers. 50 were randomly chosen to refrain from eating eggs, while the other 50 were made to eat at least 2 eggs to get day. So again, we have a scenario in which we have two distinct groups here. They're not paired, they're not doing the same thing together. So I've got my two distinct groups here. So this is definitely a two-sample procedure. When it says it's how much greater, it's also the average, how much greater, so I want a number there. If I want to get a number, I have to create an interval. So two-sample t-interval for means. This one, how many more, another keyword there, calories do people consume on days that they exercise versus days without? So they had 600 participants, one sample, and it was charted for a day when they did exercise and a day when they did not exercise. So this is like a matched pair scenario because we have 2 data points on one person, but we also want how many more. So we're doing an interval here. So it's a one sample t interval for means. Okay? Alrighty. That is it for this one.